Good morning, all. I hope everyone is well, and similar to myself, you've got a lovely big cup of coffee here. Welcome back to another one of our CPD webinars, this time all about defects in cavity construction. I'm your host, Andy Ferguson, and joining me today, I am blessed to say we've got James. Morning, James. Oh, James, where have you gone? You make me worried here.
Morning, Andy.
I thought you'd disappeared. Folks, just to kind of give you a wee bit
I
of
am
a
here.
background.
Can you hear me?
We've been having some technology gremlins this morning, so we are starting just a couple of minutes later than what we actually thought. So I do apologise, but a big hello to everyone that's actually joining us now. I can see we've got a good number on at the moment. Um, uh, Again, this is the next on our CPD webinars, defects in cavity construction. Big welcome to everyone joining us. If I can just maybe point everyone out to just a few bits and bobs. We are always keen to kind of hear from you, any questions you've got, etc., etc. If I can point you over to our chat facility that we have now, if you're on a desktop, that chat facility should be either on your left-hand side or right-hand side, really depending on the settings on your PC. If you're using a mobile device, however, if you just kind of just scroll up just a little bit, just that tiny little bit, you'll see that there's a little text box in there, chat box, that you can basically type away to your heart's content. Just jump on. If you just want to say hello, say hello. If you have anything you want to say over the course of the presentation, please do jump on. If, for God's forbid, that you actually might disagree with anything that we're actually saying, or I should more or less point out anything that James is actually saying, then again,
We don't want to encourage that.
No, well, yeah. What was that, James? We don't want that. Oh, I kind of
We don't want to
missed
encourage
that.
people to disagree with us, do we?
No, I don't think we want anyone disagreeing. No one would really disagree with us out there, would you? So, and then please don't feel free to jump onto the text box and actually say that. But guys, we are just waiting.
Of course they can. Everyone's allowed to do it.
Yeah, so James, I think we're still having those technology gremlins. I think there's a small delay just between you and I in the kind of chat, just going back and forth. So I do apologise if I'm speaking over the top of you. Guys, we're just to let you know, we're just waiting a couple of minutes just for others to kind of join. I have just noticed that we have had a bunch of individuals that have just joined us. Good morning, everyone, and welcome to the next in line of our CPD webinars, defects in cavity construction. Just if you're wondering who is on just a moment, I'm your host, Andy Ferguson. Joining me today, I have James Berry. For all the newbies just jumping on, I do apologise for everyone that's just heard this spiel. If over the course of the presentation you do want to chat to us, you do have any questions whatsoever that's burning away, the chat facility is your place in which you can fire those questions over to us. Again, if you have a desktop, that chat facility should be just on the left or right hand side, depending on your settings. On a mobile device, all you simply need to do is just scroll up that little bit and you'll see the chat facility in there. It's not the only way in which you can actually engage with us as well. If you so chose to do so, you can actually email any kind of questions over to us. Just simply email it directly to myself, which is just at andy@property-care.org. That's andy@property-care.org. There is another way which, if you so chose to do so, if you want to do it, you can actually get in contact with us via our social media channels, either via Twitter, LinkedIn, or Facebook. All you simply need to do is basically just hit the search functionality, just type in Property Care Association, and we should pop up. Just throw in your questions there. We are listening. I'm actually thinking my spiel is probably getting us on to nice timing here, James. I'm just looking at the time here, 9:03. I suppose without further ado, I will pass you over to our key presenter today, James Berry, and his presentation on the defects in cavity construction. Over to yourself, James. No.
Thank you very much, Andy. I'm hoping you can all hear me okay. A few panicky moments this morning. Can you hear me?
Yeah, we can hear you.
Well, Andy's disappeared, so I assume that's good news. So, okay, perfect. So it's great. You know, we've broken 200 this morning. It's great to have so many of you logged on. It's brilliant. It just goes to show, you know, a bit like Tiger King, really, isn't it? Incredible what people will watch when they're in lockdown. So there we are. Cavity walls. Move on to the next slide. There we are. So cavity walls. Why cavity walls? Well, of the 27 million homes in the UK, it's estimated that nearly 20 million of those are cavity walls, and having or hollow walls, as they were referred to in the early days. But having looked through the attendance list, or those that have registered this morning, it looks like the vast majority of you are surveyors in some guise or other. But with that volume of cavity or that form of construction, we're all going to be looking at it on a more or less daily basis. So it's something we all need to be familiar with. And it stood the test of time, as it were. It's been our predominant form of construction since the 1920s. And it's, for the last 100 years, it's what we've been using, and it's our go-to method of construction still. But why? Well, a couple of reasons, really. If you start thinking about what we had before, particularly with solid walls always worked on the premise that you had a wall that would get wet, dry, wet, dry, wet, dry, but it always had to work that it would dry quicker than it would get wet. Otherwise, you'd have dampness manifest itself on the inside. However, you know, it didn't take much for that to get tipped out of balance. With a cavity wall, you obviously have an outer leaf and an inner leaf. And you had an outer leaf that gets wet, dry, wet, dry. You have a void. And in theory, the inner leaf would always remain the same and would always remain sort of constantly dry. There are additional benefits as well, additional sort of considerations while they moved to this form of construction. The first was thermal benefits. You had two leaves and you had that cushion of air there, which provided some form of insulation as well. So, you know, some thermal benefits to that. And of course, like everything else, the third reason was essentially they believed it's cheaper. Fewer bricks. So like everything else in the world, it was governed by finances. But it's worked. It's been brilliant for our sort of maritime climate, as it were. And this is a little case study of that, really. This is one that our own Steve Hodgson went to look at. And that was in Hull. Bear with. So this was one he looked at for a Channel 4 programme for Sarah Beanie. He was asked to go look at it for Woodworm. And being Steve, it was, you know, looking at the dampness as well, that he said you can just about make out there's quite a lot of substantial trees surrounding the property, but it was in a pretty poor state. So you got the bay window was essentially falling off. You got all manner of other defects on there as well. So you got as you can see, staining behind the downpipe. You got cracking to the render. By all accounts, it was virtually falling apart. But despite all of that, it was dry on the inside. And that's because cavity wall construction is proper robust. It really does work. It's fantastic. It's stood the test of time. And I believe it is the Garden Village. Yes, well spotted. But more curiously, I mean, has anyone seen these sort of types of tie before? Very unusual. But rat trap we'll get onto in a minute, Les, so don't you worry about that. But moving on, so cavity wall, I've sort of said that it's been, you know, we've been using it as our primary form of construction for the last 100 years. But what's the earliest examples that you guys are aware of? And you know, this is sort of throwing it open to conversation in the comments section, really. So what's the earliest example that you know of, that you've heard of? Let's have some comments coming in, you know. We certainly know there's some examples before 1920s. Is there a delay on the comment section here? No one wants to talk to me this morning.
Well, come on.
1900, yeah, okay.
Yeah, well, just to kind of let you know, James, I think there's just, I think there's just a wee bit of a lag.
1870s. There we are. We've got a few coming in now. Real County. 1819, 1890. Yeah, so we're all in that sort of similar ballpark, aren't we? 1890. Well, I'm going to talk about my good mate, Marco Vitruvius Polo. And for anyone that sort of knows, you know, a bit of a cruel question, because I don't suppose that many of us look at sort of Roman architecture on a daily basis. But my mate Vitruvius, and if anyone, you'll start to realise I'm a bit of a fanboy for him. He was just a bit of an all-round genius. Military commander, Roman architecture or architect. And he wrote this, the 10 books of architecture. And what he realizes then is that actually to try and cure dampness, if you've got a state of dampness all over the wall, you should be building construction with 2 tiers, 2 leaves. But more than that, he actually starts to realize that dampness can then manifest itself within that cavity, and he starts talking about the need to ventilate it as well. So this, you know, just a mere 1900 years before it caught on in Blighty, the Romans had already thought about it, and our mate Vitruvius. So, you know, didn't take long to carry on. Just a quick word to the wise, really, and I know Les has mentioned it previously. Identification of cavity walls. It might seem obvious if you've got a stretcher bond, you know, it'd be fairly straightforward. You're either at 4.5 or you've got a cavity wall. But don't be deceived, particularly with headers, for several reasons. So you've got that diagram in the bottom right corner there. That's from the Gwilt's Encyclopedia of Architecture from 1899. And you can see you've got these quite ornate type bricks that are used for an early form of tie, essentially, to keep those two leaves together. But from the outside, you would be quite easily forgiven for thinking it was a solid wall. And same with the one on the left. This is actually from the London bylaws in the 1920s. And what that advocates is building essentially a solid wall, having the cavity behind that, and then having a 4.5-inch leaf behind that. So ultimately, you know, don't be deceived by headers. And the best way of always checking is to do the measuring. Check the depth of the wall. You know, don't want to teach Granny to see. You know, John's off. Mentioned that, yeah, quite often comes about, and it was advocated in the London bylaws, so that's why. So make sure you measure. Absolutely, gospel way, you've got to do it. So that's a bit of context, a bit of what we're looking at, bit on cavity walls. But I promised you defects, so let's start looking at defects. So this is from my good friend Jervis, and this is a series of bungalows, social housing bungalows in Croydon, which I'm led to believe are no longer there. But you might see not particularly exposed location-wise, relatively built up, not particularly high either, but you can see just a small amount of deflection in that roof line there, particularly sort of at the ridge line. And that's it in closer detail. You can see just slightly pulling away. And here's another example, but on this one, they've put some loading on it. So you can see they've added that rather substantial aerial and some form of utilities box there as well. And you can see that's that one in a bit more detail. So with that loading, that is starting to pull away. And then eventually the inevitable happens. And you can see the aerial sort of lying down there on the bushes, as it were. But that happened due to one small omission. And the one small omission on that was it omitted wall ties. No wall ties have been put into that wall. If you think about it, that's due to the slenderness of a 4.5-inch wall. If you put it up and it's not linked to the supporting structure where there's sort of retaining walls or internal walls to strengthen it, there is very little strength there. And here's a another more famous example of that as well that we've seen fairly recently. So this is the Oxgang School up in Edinburgh, where it was built happened in 2016, modern construction, and happened because there were too few wall ties put in there. And the result of that, I mean, luckily there were no children injured. It was a result of storm. Well, it wasn't a result of Storm Gertrude at all. It was a result of poor workmanship and a lack of ties. But ultimately, it caused 17 schools to be shut in Edinburgh and 7,000 students were affected. So that's the implications of such a minor defect, which is integral to a cavity wall. In cavity walls, I mean, what are the causes of failure? The two we've just looked at are simply an omission of ties or not enough ties, which is one of the more common ones, but it can be down to distribution of ties. Another common reason would be mortar type, particularly black ash mortar. I did have photos of Oldham College, but they're quite old. I went for some more recent case studies, Les. And of course, the good old British weather as well is probably one of the major causes of wall tie failure. I'm kind of glossing over this purely because there's so much we've got to look at today that we shan't go into too much detail, but essentially BRE Digest 401 is the wall tie replacement Bible. And if you're looking at this sort of thing, you've got to be familiar with that as well. But what are the signs? They're the causes of failure. What are the signs? So starting on the right-hand side there, you've got the classic horizontal cracking in the mortar joints, and that's your fairly typical signs of wall tie failure, or expansion of wall ties, I should say. And it's even more prominent. You can see it sort of across that course there, but particularly if you've got rendered properties, that becomes particularly prominent and fairly easy to see. On the left-hand side, you've got what we call the pagoda effect. If you can imagine, once a wall tie corrodes, it expands. And that causes that pushing up, which you're seeing on the mortar joint on the right-hand side. But you can also see it in the roof line as well, and you get the pagoda effect. Similarly, that expansion, you can see in the gable wall that the middle property as well, where bulging is another symptom, another sign. One thing I also wanted to touch on, and it's something I did allude to sort of briefly when we did the damp control webinar a couple of weeks ago, is you've got all these ties, and if you look at the design of all these ties, they've all got one feature on them, which is some form of damp control. You've either got sort of the rubber beads, you've got the twist, you've got something there to drip water to make sure that water does not run across that tie from the outer leaf to the inner leaf and dampness manifest itself internally. And it's meant to be dropping water into the cavity. So there is some form of, the cavity is there for water control essentially. And that feature is there for it to discharge water into the void. But another feature, and I think one that probably doesn't get enough attention for moisture control within voids, is cavity trays, and particularly detailing on cavity trays. So this is taken from an LABC document, so you'll have to excuse the quality. It's not that great, but you can see these diagrams in the top right-hand corner there. But you can see the damp patch around the window penetration. So above all penetrations, you should really have a tray, and you need to make sure that there's sufficient weep holes in there. You need to make sure that the sides of the tray are not going to allow water to run off the side, which I believe is what's happening in that right-hand corner there as well. So I think cavity trays are another form of moisture control within cavities that are often overlooked and can be responsible for moisture building up if not looked at properly. Again, another poor detailing with regards to cavity trays, particularly on corners. So you can expect to find it above penetration doors and windows openings, that sort of thing, but also on corner junctions as well. You've got an ability for, depending on how that's sealed, that should really, there should be some form of the corner there to prevent water running down. And again, that's from LABC documents as well. So talking about sort of window openings, things like that. So lintels, another important thing. You can see on the left and the right hand examples there, you've got forms of cavity trays. But on the middle one, you've kind of got this integral cavity tray, as it were, for it to be able to discharge water. But the thing with those the two property, or the two samples on the examples on the left, is you've inherently got a built-in cold bridge there as well. You've got a lintel that's straddled across the cavity. It's naturally going to be a few degrees colder as well. So if you're doing your survey, you've got to bear in mind that you've got an inherent defect there as well. So if you're out there doing your survey and you've got you're lucky enough to have a thermal imaging camera, you know, you should be able to pick up on something like this if you've got a concrete lintel going across the two. But if not, you know, you can still do similar things with a simple surface thermometer and check above window lintels, check for temperature differentials to see if there's an inherent built-in defect there as well. So that's a lot, sort of, well, I say a lot, that's sort of a brief overview on inherent design features for, sorry, let's jump forward a few slides. So that's a lot about the inherent defects within the structures, as it were. But what we've also got to bear in mind is that we've also changed a lot of our construction as well, particularly cavity walls. And I'm going to put a big caveat in here now as well, actually, because you get quite a few people that are quite anti-cavity wall insulation. And I don't see myself sitting in that camp by any means. Actually, I think there is a huge move towards being more carbon neutral at the moment. And I think perhaps, well, no, not perhaps, I think rightly so. And I think that's something we need to embrace. But part of us embracing that, and if we're ever to get anywhere near our carbon neutral desires, what our aspirations are, we need to look at our existing housing stock. Now, our existing housing stock, as we've already, is quite old. The vast majority of it, over 85%, I think, is over 20 years old. And that needs to be improved, thermal efficiency. And cavity wall insulation provides one of the most cost-effective way of improving the thermal efficiency of a building. So does it have a place? Yeah, absolutely it does. However, what I think we all need to bear in mind is that it fundamentally changes the way that wall operates. We spoke earlier how a cavity wall works on the premise that you have an outer leaf that gets wet, dry, wet, dry, wet, dry. And then you have a void, and then you have the inner leaf. But as soon as you put something in there, retrofit insulation, as it were, you then have a means for moisture to then get across that void. And it's important to bear in mind that that changes the mechanics of that wall. So suddenly those that are occupying those buildings, those that are inspecting those buildings, or those that are or specifying the insulation, all need to be aware that they're changing the way that wall works. And what it does do is, you can see that this insulation here, hopefully the video will work. You can see how wet that insulation can get if it's put in inappropriately, or if the external maintenance of the building is not maintained. Now, hopefully you should have another little video now. So this is a result of a gutter leak. If you start looking at this, so what's the cost of a routine gutter leak? I mean, hopefully it should be picked up as part of your routine maintenance. So if you're doing your routine maintenance, you should be checking your guttering once a year or whatever, and hopefully the cost of that repair should be free. But in this instance, you've got to start considering the cost of the extraction of the insulation material. You've then got to start looking at the cost of the replastering as a result of that. You're also then going to need an electrician to check out any of the electrics to make sure they're still safe and sound. You would then need to consider any built-in timbers as well. So there's an extra trade there. There's probably a plasterer is going to need to come in there as well. So there's another trade. And then you've got your wall ties there as well that may potentially have been affected as well. So something that ultimately should have been picked up as during routine maintenance and would hopefully, essentially be a free fix. The cost has gone up exponentially, and this is why it's fundamentally important to appreciate that cavity wall insulation will change the way that wall works and the importance of good maintenance. I mean, on that, the subject, diagnostics of cavity wall insulation, as it were, there seems to be a lot out there on sort of failure of cavity wall insulation. Let's say, I don't sit in the camp that it's all bad. I think there is absolutely a time and a place. I've had 2 houses with it and never had a problem. But with regards to diagnostics of how do you distinguish, and the vast majority, CIGA, the Cavity Insulation Guarantee Agency, tell us that 50% of their claims are down to rainwater penetration. So that's where the majority of claims. But how would you distinguish between rainwater penetration and say, internal atmosphere? Well, condensation and mold growth problems. Well, for my mind, the only way you're really going to get a positive diagnosis on that is you're going to need to, well, you can try and get an endoscope in there, but I don't think you'll tell much from physical appearance. I think you need to do what's happened in this instance, and I think you need to remove a brick. I think you need to get your hands on some insulation. If the insulation has got wet through rainwater penetration, you're going to see it's wet. You're going to see it's like that. You're going to see there's some problems. Just a bit on the main types of cavity wall insulation then. So you've got your expanded polystyrene walls that you can see there, and then you've got your mineral wall as well. They're your 2 main types that you're likely to come across. Both will allow moisture to get across the void. Mineral wool will act more like a sponge, and for my mind, it will hold more moisture. The other thing you've got to bear in mind with the mineral wool as well is that ultimately, once it gets wet, it's going to get heavier. When it gets heavier, it's going to drop. When it drops, it's then going to create, well, not only are you going to lose any thermal benefits that insulation would provide, but it's also got the potential to then drop and cause problems with continuity of the insulation. There's going to be cold bridges potentially where there's voids and missing gaps. The third type is urea formaldehyde. Now, you're less likely to find this essentially expanding foam, which you're going to get injected into a cavity. This should only be used in really sheltered areas. I'm not a huge fan of this, but ultimately, it seems to break down over time anyway, and then you're going to lose your thermal benefits. But imagine if you realise it's gone into an inappropriate property within the first few years, how are you ever going to get that stuff out? The job of removing that stuff is going to be quite some pain. I'm going to go back to cavity wall ties now. You can see, I think cavity wall insulations have an impact on cavity wall ties. I think I briefly alluded to this when we spoke a couple of weeks about the last webinar. But as I say, all of these wall ties are built with an inherent drip feature to allow them to discharge water into that cavity over time. We also know all galvanized wall ties have a life expectancy. That will vary depending on location, but they will need replacing at some point. And that's, according to BRE, they say they probably will need replacing at some point within their life. So if you've got a property where you've got CWI in there as well, and you've got your wall ties, how is that drip feature actually going to work? How is it going to be able to discharge water when it's got the insulation around that? I think that's going to hinder that process. I also think that you need to start looking as well at a bit more context as well. So we know if we've got a property between 1964 and 1981 where standards of galvanization were reduced as well. So if you're looking at that, say, particularly of a property of that era, as a surveyor, do we have a duty of care to say, ultimately, you should be looking inspecting your wall ties on a more frequent basis. We should be suggesting that they're checked anyway. They do have a shelf life. They're not expected to last forever. They have a life expectancy. Should we be encouraging, do we have a duty of care to suggest that the wall ties are inspected on a more frequent basis? And now, to my mind, I don't know that there's been enough research on that, and I would like to know the long-term implications of CWI on cavity wall ties, and whether there's an issue there. But a few considerations with cavity wall ties or cavity wall insulation when it comes to wall ties as well, particularly in wall tie replacement as well. So if you consider in the example we've got here, we've got an iron wall tie, or fishtail style tie, I should say, which is completely sheared, but it's quite a substantial tie. In this case, it's going to need removing. So how are they going to do that? Well, they're going to need to remove the brick. They're going to need to get in there, and the chances are they're going to remove some insulation as well to be able to get access to it. So once they've removed that insulation, with the best will in the world, you know, how many contractors are likely to replace that insulation? And that's no discredit to wall tie replacement. And, you know, there are some cracking ones out there, but I think there's probably some that aren't as great as well. And with the best will in the world, are they likely to replace the insulation they're removing when they're looking to get these ties? I would say it's unlikely. So all they're going to do is any insulation needs to be continuous. If it's not continuous, it's not going to be able to perform its function, and you're going to have temperature differentials. And that's going to result in potential cold bridges, particularly when you've got vulnerable metal elements as well. And another one, you've got wall tie replacement work going on. So if someone is putting in a new wall tie with the best will in the world, and the BRE guidance says even the most careful contractors are always going to knock a bit of debris into the cavity. And if they knock debris into the cavity, it's going to do one of two things. It's either going to sit on the insulation and potentially act as a bridge to allow moisture to get across, or it's going to sit on that insulation and the weight of it will push it down, again, creating voids and holes in there. So I think there are sort of a few considerations when it comes to wall ties, wall tie replacements, and CWI. So another little case study now. So this is a 1970s bungalow in Wimbourne, not particularly exposed by any means, you know, quite sheltered by the neighbouring property. And judging by the satellite dish, you know, it's probably a southerly elevation as well. So this is a drill got into one of the mortar joints. You can see that external face is absolutely saturated there. And this is, you can see the hole, you can see some of the insulation. Now, I know there's going to be a few people that are probably going to be straight on the bandwagon and blame the cavity wall insulation. The insulation should never have been put on. Now, this is where I sort of kind of think of things a bit differently. Now, you can see on this one, it looks like someone's come along and done some repointing there. In some pretty dense cement render there as well, which I think is going to hinder that wall's ability to be able to dry. And I think that's illustrated even more so when they've taken away that render, and you can see how soft the mortar is behind it. So for my mind, I think actually, whilst, you know, there'll be a lot of people that are quick to blame cavity wall insulation in this instance, I think actually there were alterations to the wall that probably had more of an impact as well. So I don't think it's just the CWI and insulation. In this instance, I think there are numerous factors that have caused that. This just gives you a bit of an indication as to the extent of sort of the amount of water that the insulation can hold as well. And extent of the internal damage, so you can see, hopefully see standing across the length of the wall there. And again, you can see it down at the base, it's saturating the carpet there as well. Cavity wall extraction, we like to include this little video, and hopefully you can see it, because a lot of people wonder how cavity wall extraction takes place. Well, essentially, you get two guys. You get one with an air lance and one with a great big hoover. And they come along. The little black sort of sea anemone things are essentially used there to fill the existing holes when it's sort of blown out. You can also see where he sticks that lance in and the amount of debris that comes out of that cavity as well. But we'll get onto that in a bit more detail in a short while. The other thing to consider, so the reason for cavity wall insulation is it's all about providing thermal benefits and becoming more carbon neutral. And when you start thinking, once it's gone in, which is fine, and there's a benefit, but if it has to come out, if it's got wet and it's going to come out in this instance, what's happened to all the carbon benefits? Because where's this stuff going to come and go? You know, the amount of time, effort, and work. But this stuff that's going to come out, where's it going to end up? It's probably going to end up in a landfill somewhere, and that can't be particularly carbon friendly. Another consideration, or another thing that a lot of our members have pointed out to us, is a lack of consideration around air vents, particularly sort of after CWI works. You can see the picture on the left is sort of suggesting that, you know, a lack of consideration, but we know that air bricks provide an extremely important function on ensuring the life of a suspended timber floor. It's paramount, absolutely vital. And they should be sleeved if they're there to perform a purpose. And if they're not sleeved and not isolated to continue to allow water to flow through, then air to flow through, then, you know, you're going to restrict and you're going to end up with timber decay for the floor. So, you know, as part of the surveys, if you're looking at cavity walls, I think you should always take a prod just to check that the air bricks aren't blocked. So moving on from CWI, I briefly touched on some of this. This is a diagram from BRE Digest 245. Again, great document, but this sort of gives you an indication of why you might find dampness at the base of a cavity wall. You can see that the top two, essentially bridging by floor screed, are pretty self-explanatory. If you come along and you've got something that allows water to bypass the DPC, then you're going to allow water to bridge it. The bottom left-hand corner one is internal plaster bridging the damp-proof course. And again, I'm sure many of us have seen this all the time. It's quite a common defect. We all know the remedy for that is normally just to remove the bridging plaster. But it's this bottom right-hand one that I'm going to look at in more detail, and I alluded to it when we did the webinar a couple of weeks ago. Bridging by debris in the cavity, I think, is far too often overlooked for my mind. And I think if you're ever looking at a dampness problem in the bottom of a cavity wall, you should always be inspecting the cavity. Now, this is a case study of a fairly recent property as well, a modern property. But you can see the sheer amount of debris that gets dropped in that cavity during the build process. And I think, you know, hopefully that gives you all food for thought. But you can also see in that right-hand picture, you've got a weep hole there on top of that cavity tray. How on earth is that ever going to perform its function? Because it's, you know, water is never going to get past all that debris that's in there. So there's a lot of moisture there. I think for any inspection on a cavity wall, you know, I appreciate it's not always easy, but an endoscope, anything like that, should always be ruling out that the dampness is being caused by debris within the cavity. And again, this is just another example. Again, more debris within the cavity. The other thing you can see on that right-hand picture as well, which is the position of the wall tie. Wall ties ideally should be either level, or they should be running with a drop from internal leaf down to the external leaf, because in this case, you can see the moisture dropping down. It's going to run along that wall tie and potentially onto the inner leaf and cause an issue there as well. So huge problems potentially with debris in the cavity. I think it's not one to be underestimated and should always be looked at, and regardless of the age of the property. And, you know, what about remediation? If you look at this job here, you know, there is a significant amount of work that needs doing there. The answer there is not, you know, new DPCs or anything like that. The answer there is removal of that debris. And it's quite a laborious job. But there is a good amount of work that needs to be done there. And that's always going to be a more permanent fix as well. So I appreciate this has been a bit of a whistle-stop tour. It was always going to be that there's a whole lot more we could have gone into with regards to condensation and, you know, with lintels and things like that, crack stitching, lintel repairs, that sort of thing. There's a huge more depth of information we could go into with regards to defects and cavity walls, but I appreciate we've been going on for a little while. So if you want to know more about this and want to know in more detail, we were hoping to run a course early this month, on a full day, 1 day course on defects in cavity construction. And we were looking to run that earlier this month, but as you can understand, circumstances meant that we weren't able to do that. So we're now looking to run the first of our defects in cavity construction course on the 4th of August. So I'm hoping today has sort of whet your appetite, given you a bit of a clue as to the volume and some of the defects that you can find in cavity cavity walls. And if you want to come and find out more and come along and speak to Jade at property-care.org. And I'm sure Andy will post her address in the comments for those that are interested in doing that course, which is 4th of August. But if not, thank you very much for listening, and time for some questions.
Oh, hello everyone. James, many thanks for that presentation. Folks, just before I jump into questions, just want to apologise for anyone that was having any kind of sound issues over that presentation, and many thanks for everyone kind of bearing with us. We were having some technology gremlins this morning that we were trying to kind of iron out. It looks certainly from the very start of the webinar, those gremlins were kind of continuing with us, but hopefully similar to myself, it would have ironed out hopefully for you over the course of the webinar. But kind of moving on.
Well, we've still got over 200 people logged on, so I'm hoping they can't have been too bad. Otherwise, we would have had a few people.
I did notice that as well. Hopefully, it was just the few of us that were having these kind of issues. James, just to kind of let you know, just the technology, I think there's a little bit of a time lag, just going kind of back and forth. And also, guys, just for the audience, if you're wondering why there's maybe a time lag between me posing a question and James answering it, that is the reason. But kind of moving straight on to kind of questions. We've had quite a lot of questions that are coming in, some to a kind of similar theme, but let me start off with the first one from Scott Ormston. Can cavity wall ties be fitted through cavity wall installation?
Yes.
Oh, as basic as that?
Yeah. You know, driven ties will go straight through it. There's no issue there. That would be fine. Of course they can. But I just think, you know, it's an extra consideration that you will have issues there. You know, there are extra complications if you've got cavity wall insulation. So I think you just got to bear that in mind.
Well, a theme that was popping up just within the chat actually to do with inappropriate ventilation, James. I think if I summarise just some of the comments, which was cavity wall insulation generally needs suitable ventilation methods that are typically inappropriate. I mean, what would you suggest is suitable ventilation methods if you do have cavity wall installation or you come across it?
Okay, so cavity wall insulation needs suitable ventilation measures, which are usually inappropriate. Okay, I'm not really sure what that, but I kind of, yes, I agree with the sentiment of what I think that is saying. Yes, and one thing I didn't really have enough time to go in, but yes, any retrofit insulation measure is normally done as a suite, or should always be done as a suite of measures. if any sort of the draft proofing of any property, anything like that, you're reducing air exchange within that property. You're inhibiting the ability of that property to discharge moisture from that internal atmosphere. So yes, absolutely, you need to be able to then make sure that you can get rid of that moisture in other means, which is via ventilation, normally mechanical ventilation, a system in accordance with approved document F, ventilation of the building regs. And yes, it is normally usually inappropriate, which are usually inappropriate. And so by that, I assume he's saying that they're not normally put in properly. Yes, I would agree. I think approved document F is the most sort of, or the least reinforced approved document. I think that's completely backwards. I think while approved document B has got all the attention because fires are dramatic and big, but ultimately part F is vital to the health of the occupants of the building as well. We know even in new builds they're not getting it right. There's been numerous studies on that, and yeah, I would like to see more enforcement of approved document F. I think, you know, I would like to draw attention to that. So maybe I've misinterpreted the question, but it gave me a chance to go on a bit of a rant about something I feel quite passionate about, so I'll take that.
Well, no worries. Well, I'm not going to pretend I know more than yourself, James, so I'll just take it with a pinch of salt. But guys, if you do have an opinion on it, then feel free to jump onto the chat and let us know. Tell us what your thoughts are. Tell us what your feelings are. One from Robert Horn. Now, this is going to open up a can of worms, I suppose. He's thrown out here that one has to ask why cavity wall insulation is allowed if it absorbs and holds moisture from any source. Feel free to open that can of worms, James.
One is to ask if it is all. I was trying to be keen to, and particularly in the presentation, I'm not anti-CWI. You know, I've had a couple of properties that have had it in. I've never had any issues. And I do actually think there is a bigger picture as well, you know, which is improving the thermal efficiencies of our existing building stock, which is, you know, in some cases really, really poor. If it absorbs and holds from, and it's down to maintenance. This is, I think a lot of it is down to its education and making sure that everyone is aware that it does change the way that will work. So I think it's got to be allowed. I think it's got to be embraced. I just think there needs to be more education. So it's all about maintaining the external fabric of a building. I appreciate that. That's going to be more and more difficult going forward. You know, millennials, I'm going to say this, and I'm going to give millennials a kicking because I am one. So I think that gives me a prerogative to be able to do so. But most of us aren't very good with regards to hands-on stuff, particularly building works, that sort of thing. But I think there is a place for it. But I think it's got to be looked after, and I think people need to appreciate that you've got to look after a building more so when you've had it installed.
And you know, guys, just to kind of throw it to my 10 cents there, I agree with James as well. Yes, as much as there is lots of problems, and they do get highlighted on the media and etc. with cavity wall installation, certainly from my experience, if it's done right and it's done proper and it's done well, then certainly from my very, very limited point of view, it's certainly worked effectively for me. I've got a wee bit more of a quirky one coming up here, James, and I think this will appeal to your nature. One from Chris Feathers, and he asks, now, pardon my pronunciation because I can't quite remember the chappie's name, but it's your hero at the beginning. But he's asking, I wonder if the Romans, and in particular, is it Vitruvius, would have to say about cavity wall installation. So if you could actually meet him right now, what do you think he would say about it?
That's quite an interesting question. Well, you know, actually, as I said at the beginning, the man was just an absolute genius. But he had already identified the requirement for cavities to be ventilated. Even, you know, 2,000 years ago, he was fully aware of that. So actually, I don't think he'd have much love for it. And bearing in mind that the Roman climate is probably a bit more humid or a bit warmer than ours anyway, so there probably is less demand for it. But yeah, no, I think he was very much of the opinion that the cavities needed to be kept clear and they should be well ventilated to stop dampness manifesting in them. So I suspect he probably wouldn't have been a fan.
Yes, I suspect you might be right. One that's just come in from Andy Booth. James, what are your thoughts on bonded beads cavity wall installation?
Well, I think they would still allow moisture to get across. They're probably the one that I would choose if I was having one fitted. You know, I'm not. I think there's a time and place. I think, you know, each should be taken on their merits, as it were. The other thing, you know, they're the same as a, you know, I'm not strongly opinionated on them either way, to be honest. I don't dislike them. I don't, you know.
Well, folks, again, this is your opportunity. We don't pretend to be experts in absolutely everything. So if you know a little bit more, feel free to kind of join the conversation. You know where the chat functionality is. Throw your comments out, and we're happy to discuss. Got a question here from Stuart McGinley. Again, this might be this might be.
Is there a way of dissolving the urea foam insulation?
Yes, that's the one.
I do not know. So I think there's probably there might, you know, there's a lot of attendees. Someone might know. So if anyone knows the answer to Stuart's question, unfortunately I don't. But if they do.
Yeah, well, feel free to comment and feel free to throw out whatever your thoughts are. And Stuart, similar to yourself, do you know, if you have more knowledge than us on it, then tell us, throw it out, share, tell us what you think, and we'll throw it out to everyone to debate. I am a little bit unsure of the context of this next question. I think this is a non-techie in me, James, but I'll throw it out to you anyway, and it's from Christine Fennan. And she's asking, what is the time period for poor galvanization? Now, I think this came from a wee bit.
So yes, so the standards of galvanization were dropped from 1964 to 1981.
There we go.
I don't know why it was done. There was some perception that there probably wasn't a problem. But you know, they left it for 15 years and saw the error of their ways and upped the ante again. So,
well, do you know something I've tripped across here, James, and this was something I didn't actually know of as well, but one or two comments actually came in terms of seeing all the debris that was within the cavity walls in itself, and there was a few kind of walls and surprises out there. I mean, how often does this actually occur? I mean, is this a fairly common occurrence where you just see crap in between the two leaves?
I think you'll pretty much get virtually every property you'll find a certain amount of debris there. It just depends on the extent. But how many people are realistically checking? You know, it's difficult to know the full extent of the problem, because I wonder how many people are actually doing the right checks and checking in a void. But yeah, I think for any cavity wall property, if you're looking at dampness at the base of the wall, you should be checking it. So, you know, find out for yourselves how often you're coming across it. Unfortunately, with the nature of the building works, there is going to be some. It just depends on how sloppy the builder is. And, you know, I've seen photos of all sorts of debris. You know, don't get me wrong. That and behind fireplaces are a great place for builders to lose stuff that they don't want to take with them off site. Be it Lucasade bottles used to be a favourite, bits of timber. There can be all manner of things in there. You know, don't just think it's going to be snots off of mortar or anything like that. They're quite a handy place depending on who's done the building and whether he thought he could get away with hiding some stuff in there.
Okay. Next question, up from Jamie, and he's just stuck out there. Can you discuss the effects of black ash mortar on wall ties? Now, Jamie, I will tell you, I didn't even know there was such a thing as black ash mortar. So over to you, James, on this one.
I'll be frank, I don't know. It's not particularly common in my part of the world, that's for sure. But I know that it has an adverse effect, and helps sort of accelerate the rate of corrosion of a wall tie. If you're going to ask me the chemical process or on how it does it, I be honest, I don't know. But you know, other things, such porosity of a mortar joint as well can affect it. But yeah, I simply don't know. I know the effect it can have, but I don't know so much. But I'm sure AD Dawson will be chomping at the bit to answer that one for you in the comments. Go on, AD.
Well, Adrian, if that's the case and you're one that's long in the tooth in this one, then well, feel free to get in about in the comments. I'm sure you will. Next question up. Question from Henry Longton. Is it feasible to install external insulation stroke cladding to a cavity wall?
Sorry, ask that again.
Sure. Is it feasible to install external insulation stroke cladding to a cavity wall?
I'm sure you probably could. Again,
Want to, yeah?
Don't get me wrong, it's not like there aren't issues with external wall insulation as well. And if you're not careful with that, particularly, I normally, if I'm doing something on insulation, I like to add something about EWI as well, just for the interest of balance. But normally, I think Colin King from BRE said he looked at 2,000 plus external wall jobs, external cavity or external wall insulation jobs, and hadn't seen one done right. They're fraught with mistakes as well. Normally, cold bridges left at the bottom of the walls where it's not continued to floor level, round utility boxes, things like that. There is normally poorer detail with EWI than what there is with cavity wall, I would suggest. So could you do it? I'm sure you probably could, but you know, it's not that there aren't problems with EWI as well. But again, it's bigger picture. You've done properly, done well. It's very effective, but there's got to be attention to detail.
Right, okay. Just to kind of throw out there about the black ash question as well, John T is highlighting that Jarvis has actually answered the question just on black ash in the chat. I'm just scanning through it, folks. If I trip across it, I will just kind of throw it out there just for everyone to actually kind of see. We are getting to that point, actually, where we are just about to kind of finish up. I'm just scanning through the questions just at the moment in time. If anyone's got any burning last questions, now is the time to kind of throw it out here just to everyone. I'm just scanning through, James. I don't know if there's anything burning that's maybe come via email from yourself. There's a lot of comment questions along a common thread that I think we've kind of answered or via chat. Just for everyone, I don't know if you can see anything of anything.
No, I've not got anything else open, so.
Oh, sorry, James, what was that? Oh, I think we're still.
No, it looks like my computer's slowly dying on me, so.
Is it? Well, I think on that note, because we are almost at that point where we're getting to 10 o'clock and kind of closing down, I think I'm just going to throw it and say a big thank you to everyone that's been throwing out these questions over to ourselves. I'm not going to promise this, but we will certainly look over the feed as well, the question feed, and if there is anything kind of burning away that we can try and help with, then we will try to get in touch with you and kind of give you an answer over to that. Just to let you know, guys, that if you want to find any more additional information on anything we've actually talked about today, then there is a few portals you can go to. Firstly, you can visit our technical document library. The URL is just up there. It's just our website /tech.library. You can also visit our professional section where there's a whole host of information out there that you can get your teeth in about, and also the links in there to additional webinars, and also tech documents are in there. But also as well, early next week, we will have this webinar available on a replay that you can actually pass out to any of your colleagues or anyone you kind of feel that it might be of interest to. Just coming up as well, our next of our series of CPD webinars is next week, and it's all about ground gas protection. Why should we bother our ass? It's been hosted by our PC trainer Neil Salvage. 9 o'clock next week. I encourage everyone to kind of jump on board. Anyone that's within the kind of waterproofing sector, damp sector, anyone that has any sort of interest within property in itself, this is certainly one for you. Again, for all PCA members only, our Tune In Tuesday series is back again this Tuesday. If you don't know what our Tune In Tuesdays are all about, this is really our platform for you guys. It's a platform there that if you guys are having any problems, any issues, if there's anything that we can help with, well, we are there to try and help and assist you. But it's also our platform as well that allows you to hear a digest of what's actually been taking place over the last week, which typically gets done by our very own CEO, Steve Hodgson, and he tries to break it down in very simple, plain text. Lastly, but not least, I just want to say a big thank you to James for his presentation today. Most importantly, a big thank you to everyone that's been listening. I do apologize if you have suffered any technology problems or any kind of sound issues. But lastly, just please, everyone, please stay safe, stay well, and we look forward to catching you on another future webinar. Take care, everyone.